So measurement. In this lesson, so students should be able to identify and measure or calculate, and in this one we're going to focus on the measurement of volume. So volume is measured in cubic centimeters, and this is what cubic centimeters looks like. It's centimeters cubed or cubic meters, and it basically involves a measurement in 3 dimensions. So volume of a rectangular box, so if we want to get the volume of a rectangular box like a fish tank, for example, it's going to be length multiplied by width multiplied by height. Volumes of liquid can be measured with this thing called a graduated cylinder. We're going to look at how you do that. And when you're using a graduated cylinder like this, so you can fill it up with a liquid, and what will happen is you'll get this like bend in the liquid at the top. So this is what's called a meniscus. And it's very important when you're reading the measurements. It's called a graduated cylinder because you have these graduations. Okay, so these like a ruler. Okay, each line represents a certain number of mils. So when you're reading off the meniscus, you read. So you don't read at the top. You read at the bottom of the meniscus. This slight bend here. So that's what you read off. If we have a look at this here, so for example, the measurement, it contains 9.60 mils. Okay, but if you were to measure off the top here of the meniscus, you would get 9.8 mils. So it's 0.2 of a mil out. Okay, so it'll be if you don't read the measurement off the bottom of the meniscus, then you will introduce an error into your measurement and you'll get an incorrect measurement. And just when we talk about mils, so we can see each of these is a mil. So a mil is roughly 1 cubic centimeter. Okay, so if you take a centimeter and you take a cubic centimeter, so each of these represents roughly around 1 cubic centimeter. So let's look at a couple of examples. So this, for example, here represents, so this here represents like a volume. Okay, so if it could be, for example, a fish tank. So if we were to imagine, let's say this was, okay, so it has a height of, let's say, 2 meters. So 2 meters. And imagine it had a length of, let's say, 3 meters. And then it had a width of, let's say, 1 meter. So what's the volume of this going to be? So the volume is going to be equal to the length multiplied by the height multiplied by the width. So it's just going to be 2 multiplied by 3 multiplied by 1. And that would be equal to 2 times 3 is 6, and 1 times 6 is 6. So it's going to be 6 meters cubed, okay, or 6 cubic meters. So that would be the volume of a tank, for example, that has these dimensions of length, height, and width. So it's very straightforward. What's important is that you make sure and use the correct units when you're measuring volume, for example. So it could be in meters, it could be in cubic centimeters, it could be centimeters cubed, or it could be even in mils. So remember, mils, so 1 mil is equal to 1 centimeter cubed. So imagine if you had like a little box like this, or a little cube, should I say, and each side was 1 centimeter. So each side was 1 centimeter. Then the volume that box would contain would be the volume that that box would contain would be 1 mil. So if we look at something like this, so when we're looking at this here, for example, so this is a graduated cylinder. So we can see that between each division, each big division, it's like 5 mils. So that would be 5 of these little 1 cubic centimeter boxes of the liquid contained. So if we want to, we can also work out the measurements, or we can work out the volume of something like that's irregular in shape, or even something that's regular in shape. What we can do is we can use graduated cylinders and look at work calculating that volume. So in order to do that, what you would do first of all is you would fill up a graduated cylinder with an amount of water, okay, like so, and then you would measure the volume of water before it is what's called displaced. So what I mean by displaced is that when I put something into this, it's going to cause the water to rise up. It's going to what's called displace the water. So what we do is we can, first of all, we put in a volume of water and we measure that. So if we were to look at this here, so we can see that, so we have 5, 6, 7, 8. Okay, so there's 8, and we read from the bottom of the meniscus. So to start off with, in here we have 8 mils. So 8 mils of the liquid. Okay, and how do we get that? We just fill it up and we measure it off the graduated cylinder. So each big division, so 5 to 10. Okay, that's so that each big division is like 5 mils. So then this is going to be 5, 6, 7, 8, 9, 10. So each of these smaller divisions will be 1 mil. So then we can read, so we can see this, so this is 5, 6, 7, 8, so that's 8 mil. Then what we do is we take our object and we submerge it into this water after we've measured it. So we put it in, and what we can see is that when we put a stone in, for example, it will displace the water this amount. Okay, so the water goes from 8 mils up to 10 mils. Okay, so it's 10 mils here. So if you like, this system here has gained an extra 2 mils, and that extra volume that it has gained is the volume of the stone that was put into it, or the other object, or whatever it was that was put into it. So therefore, so the volume of this stone then, okay, so we want to measure the volume of the stone. So the volume of the stone is going to be 10 minus 8, which is equal to 2 mils. So this stone has a volume of 2 mils. And it wouldn't be, the reason we do it this way is because it wouldn't be very easy to measure the volume of the stone. Like, how would you go about measuring the volume? So remember, volume needs height by length by width, and we can't really get that if we take something like a stone that has an irregular shape. So this is an alternative way that we can measure the volume of an irregular shaped object. So that is the measurements of volume and how we measure volume.